Trust you are doing great. How's everything? Um, Thanks for watching my video. Please don't forget to subscribe and click on the like button. Thank you. The other time we talked about forces or force on an object, which we say force is any agent that tends to cause motion or bring an object that is in motion or uniform motion to rest. And we discussed about the types of forces. I said that the types of forces are the contact force and the force field. And one of the examples of the contact force is tensional force, the force of a push or pull, and I made mention of the frictional force. The frictional force is an example of what? A contact force. So, an example of contact force is the frictional force. Now, frictional force is actually what's friction? Frictional force is actually the force that acts between the surface of two objects of separation and that tends to oppose the motion of one over the other. It's a force that acts at the surface of two objects. This is the surface of one object, this is the other surface of the other object. Like this is an object, this is another object. And now when they come together, there's a force that acts between these two surfaces like this. And this force tends to oppose the motion. It doesn't want this one to go, it doesn't want to come. So it's a resisting force between these two objects. So the force that acts at the surface of two objects of separation and tends to oppose the motion of one over the other is what we refer to as what? Frictional force. Yeah. Not far-fetched, we have types of frictional force. We have the static or we have the static frictional force. Then we have the kinematic or sliding, or call it kinematic or dynamic frictional force. 1. Static frictional force. 2. Kinematic or dynamic frictional force. Now, without wasting much of our time, there is a formula for coefficient of friction. The coefficient of friction has a formula. This is a formula: frictional force over reaction. Yes. The frictional force over normal reaction. This is the formula. We can write it as U mu. This mu is equal to what? F over R. So that's the formula for frictional force. While mu is what? The frictional force. F is the mu is the coefficient of friction. I'm writing briefly: coefficient of friction. Yes. R is normal reaction. F is the frictional force, of course. So that's the formula. And friction has example. Without friction, we cannot work with our bare foot on the ground. It's as a result of the friction that happens between the leg and the ground. Without friction, there's no the bare foot that is running in constant motion can come to rest because there's a friction between the surface of the tire and the ground. Without friction, there's no the brake can work in the vehicle because there is a force that tends to bring that object in constant motion to rest as a result of the contact between the two surfaces. And friction also has an advantage. Yes, friction, these are the advantages. Friction has disadvantage. We have, it causes wear and tears. It brings about unneeded work in the machine. So there's some work that's done in the machine that is not needed. Then it causes heating as well. The effect of heating reduces the life of the machine. And then there are ways we can reduce friction. We can reduce friction, one, by lubricating the machine. So we can also reduce friction by using the bearing. Yes, we can reduce friction by introducing the bearing. Then we can also reduce friction by streamlining the shape of an object. Just like a vehicle, like a plane. Now look at the shape of a plane. It looks like a bell, so that the opposition to the air ahead will be minimal by streamlining it such a fashion that it can be able to pass through and reduce the friction between the body and the air. So these are the ways. And note that I said we have the static friction and we have the dynamic friction. Static friction is actually the frictional force or the maximum force needed to carry an object from rest. Is that force needed to carry an object, the maximum force needed to take an object from a rest or its original position. That force is the static frictional force. Then we have dynamic frictional force. Dynamic frictional force is the force that keeps the body in motion or in a uniform speed. That force that keeps the body moving is actually a dynamic or kinematic frictional force. And you need to know that if a body is at rest, the force needed to carry the body from rest will be higher. So dynamic frictional force is higher than static frictional force is higher than dynamic frictional force. So take note. When we move further, let's talk about question 1 now. Question 1 briefly. A stationary block of mass 5 kg is having a mass of 5 kg and is set in motion by a force of 60 Newton. The force is 60 Newton. Yes. The object attains a maximum speed of 9 meters per second. Speed 9 meters per second. Now, what is the question? The question says, let us find time. What is time? We don't know. So, we don't know the time. So, the first thing we are going to do, what is the formula for force? Force is what? S equal to mass times acceleration. The mass is given to us. The acceleration is not given, but the force is given to us. So, let's substitute. So, it's going to be what? 60. 60 is equal to what? What's the mass? 5 times A. So, at the end of the day, we have A is equal to what? 60 over 5. A is equal to what? 12 meters per second square. Yes. Having known that A is 12 meters per second square, note that the V is given to us. V is equal to what? 9 meters per second. So there's a relation between V, A, and T. And acceleration, remember acceleration is what? V, change in velocity over time. Or we can come back to our equation of motion, which is V is equal to U plus AT. You know, at this point now, the body, the mass of the body motion by, so they do not stipulate that it starts from rest. Or actually, they say a stationary block of mass. Yes, it was stationary before starting. So the initial velocity is what? U is equal to 0, V is equal to 9, A is equal to what? 12 meters per second square. So at the end of the day, we are going to have 12 meters per second, 12 meters per second square. At the end of the day, we are going to have 9 is equal to 0 plus 12 times T. So we are going to have T is equal to what? 9 is equal to what? 12T. So our T is equal to what? 9 over 12. So our T will be equal to 9 divided by 12. 9 divided by 12. It gives us 0.75 seconds. So 9 divided by 12 is 0.75 seconds. Now that's the answer to question number 1. Question number 2, that wasting much of our time. They say a block of wood weighing 4 Newton, yes, is placed on a horizontal table. Yes, it is then pulled by means of a spring balance attached to one of its ends. The block just begins to move when the spring balance records a horizontal force of what? 2.5. Now, the block just begins to move when the spring balance records a horizontal force of. So the force, the maximum force that took the spring balance from the original position is what? So the frictional force at that point is what? F is what? 2.5. 2.5. And now the reaction with which the body is reacting to the ground, or the stationary force, or the reaction of the body to the ground is what? Is 4 Newton. So at this point, reaction is what? 4. So what is the formula that relates the coefficient of frictional force as what is the coefficient of static friction? U, which is mu. Static friction, the formula is what? Mu F over R. So our F is this. So at the end of the day, our static friction is equal to what? 2.5 over 4. So 2.5 divided by 4. 2.5 divided by 4. It gives us 0.625. It has no units. So our coefficient of static frictional force is 0.625. Now, the second question is, what is the frictional force when a horizontal force of 2.0 Newton is recorded? Now, note, it has been made known to us that the force that moved the body from its rest is what? 2.5 Newton. That is, the body just begins to move when the spring balance because so when the maximum force needed to move the body was 2.5 Newton. Now they are not making it no trust now that what is the frictional force when the horizontal force of 2.0. So there's a what? A reduction in the force now. The force that moves the body from rest was 2.5. And now the spring is recording 2.0 Newton. Is there going to be, is the body going to move? No. So the frictional force at that point in time is what? Is still 2.0 Newton because the body is not going to move. There's going to be a balance between the force needed to move the body from the original position and the force applied. So the frictional force at that point is still 2.0 Newton. They say, what is the frictional force when the horizontal of 2.0 Newton is recorded by? The frictional force is, so the answer is frictional force is 2.0 Newton. Why? Because it is less than the maximum force or the static force that moves the body. That is our answer. I hope you enjoyed the video. Please don't forget to subscribe, like, and then place your comment. And stay tuned as we upload you with more calculations in physics and vast areas that looks very complicated. Thank you and see you in our next video. Have a nice day ahead. Bye.